Hello, am I audible?
Yes, Shashi.
Okay, thank you. Yeah, so hi, I'm Shashi. And in these sessions, normally I discuss one lead coding question, and then Soham will talk to all of you in the last half an hour. So that's the agenda of this Monday evening alumni technical coaching sessions. Okay, so today we'll discuss this one from LeetCode. So it's LeetCode 841, keys and rooms. It's a medium question on LeetCode. So this is the question, right? And again, it's a popular interview question actually. So companies like Google, Microsoft have asked this question. So let me show you the coding problem we have. So basically, we are given, I mean, we have n rooms labeled from 0 to n minus 1, and all the rooms are logged initially, except room 0. Okay. And here, goal is to visit all the rooms. However, we cannot enter a logged room without having its key. Also, when we visit a room, you may find a set of distinct keys in it. And also, every key will have a number on it, denoting which room it unlocks, and you can take all of them with you to unlock other rooms, right? So in the input, we are given an array rooms, where rooms of I is the set of keys that you can obtain if you visited that room. So here we have to find if we can, I mean, if it's possible to visit all the rooms. If it's possible, then return true. If not, then return false. Um, so input is, if you see, input is nothing but it's a list of list. It's a list of integers, right? And output is Boolean. That means it's true or false, right? Like if it's possible to visit all the rooms, then return true. If not, then return false, right? So let me explain this input, which is 1, 2, 3, and empty array, right? So again, this is nothing but this is input list of list. It's a list of integers, right? And we are calling it, let's say, rooms. We can call it rooms, right? Now, again, if you talk about the first list has only one number, right? So this is list 1, and this is nothing but this is rooms of 0, right? So rooms of 0 is nothing but the 0th array, or we can say 0th list. Okay. Sorry, I can. So this is 0th list we have, and this 0th list has only a single number, and this denotes the key actually. So basically, this array is nothing but, so rooms of 0 means nothing but the keys inside this room 0. That means in room 0, we have a set of keys. In this case, we have a single key, and that you can say key ID, or you can say key is 1. 1 means basically this is the key for room number 1. Okay. So if you read the question, right, it says that initially all the rooms are logged except for room 0. So room 0 is not logged initially. So we can visit room 0. Okay. So when we are uh, entering room 0, right, in that room 0 we have this key. We have a single key, and that key is 1. So if you again read the question, it says that when you visit a room, you may find a set of distinct keys in it, and each key has a number on it, right? Like let's say in this case, that key has a number 1 on it, and that means it can unlock the room number 1, right? So basically, yeah. So when we are, let's say, visiting the room 0, we found this key 1, and now with the help of that key 1, I can enter room 1 because I can unlock and enter room 1, right? So then we are visiting room 1, um, and then in room 1 we have 2, right? So basically, again in room 1 also we have a single key. So I should write like, they can write like this. So let's say basically in room 1 we again have a single key 2. That means now I can visit room 2 as well, right? So then I'll go to room 2, and then in room 2 I have the key for room 3, right? So then I can go to room 3 as well. And uh, in the room 3 again, we don't have any key. That's an empty list. That means we don't have any key. But actually, we don't need any key. We don't need any more key, right? So because we are now able to visit all the rooms from 0 to 3. So here n is equal to 4. Okay. Um, and that is nothing but the size of this input list. So size of this list will be nothing but the total number of rooms we have. And these rooms are labeled from 0 to n minus 1. Okay. And basically rooms of, so rooms is the input list we have like this. It's a list of list. So rooms of I is nothing but a list. It's ith list. And this list contains the key, I would say the keys within that ith room. Okay. And we can enter a room only if we have uh, the key for that room, right? Now let us see the second example. So here we have 1 3. So again we are going to, let's say, room 0, and in room 0 we have 1 3. That means in the 0th room I have 2 keys, right? Okay. That means, let's say, I'll go to room 0, and then I can go to room 1, and then let's say uh, room 3. Okay. Now again at room 1 we have 3 keys, right? So from room 1 I can go to room 0. That means, I mean, basically room 1 has 3 keys, right? I can go to 0. It has key for room 1 as well, right? And then it has also key for room 3, right? That means from room 1, I can again go to room 3, or actually, we already have keys for room 1 and 3, right? So these keys are not useful because we already have entered. I mean, actually, so from here, I mean, again, like here also we had key for room 1 and 3, and here also we have keys for room 3 and 1, and so yeah, so basically these keys are not helpful. Also for room 0 is already unlocked, right? That's the first room. So basically the keys in this room are kind of useless because uh, we already had keys for room 1 and 3, right? Um, now from again, let's say from 0 we are going to room 1, and then from 1 I can go to 3, right? Um, but there's no key for room 2, right? So let's say here we have room 2, so we can't go to room 2, right? Because we don't have the key for room 2, right? That means we can't go to room 2 because the key of room 2 is within that room itself, right? Okay. And then in the third room also we have, like in room 3 we have only the keys for room 0, which was unlocked already. So this is also a useless key. Yeah, so in this case actually we are not able to visit room 3 because we don't have key for room 2, and that's why output is false because it's impossible to visit all the rooms. In the example 1, uh, we were able to visit all the rooms, and that's why output was true. And in example 2, it's not possible to visit all the rooms because we can't enter uh, room 2. That's why output is false. So I hope the problem is clear to all of you. Just to explain again, like in the input we'll have a list of integers, uh, and that like rooms of I denotes the ith list, and this list contains a set of keys. Okay, like room of 0 here is 1 3. That means in 0th room we have 2 keys, 1 and 3, and that means now we can visit these 2 rooms, 1 and 3, right? And then we in the room 1 we had some keys, in room 3 we had some keys, but in these rooms we don't have key for room 2, and that's why we can't go there because we can't unlock room 2, right? And that's why the output is false. So I hope the question is clear now. For late joiners, I'm discussing this one, LeetCode 841, keys and rooms. Okay, any doubt in the problem statement, anything which is not clear?
Sasi, example 2, can you repeat a little bit one more time? 1, 3, the first.
So basically in the 0th room, yeah, in the 0th room we have 2 keys, 1 and 3, right? That means now I can, go to room 1 and 3 because I have the keys.
Okay,
So
got
let's
it.
say,
So it has 2 keys. We can go room 1 and room 3 also.
yeah.
That is 0, 1, 2, 3, 4, 1, fourth one.
Yeah, 3
The
means,
means 4.
3 means the last one, yeah, the
Yeah,
fourth
fourth
one.
index.
Yeah.
Yeah, right.
Yeah.
Okay.
And in room 1 we had again these 3 keys, but we don't have any key for room 2, like that's why we are not able to enter room 2. Okay, so looks like the question is clear. So any thoughts, anyone, how we can solve this? So I'll write the example one. Sorry, go ahead.
Are we thinking about recursive solution?
Anything is fine. I'm not looking for any particular solution. So anything is fine.
One approach is like we can just have like 0 in the queue first, and since we can basically visit 0, we put it in the queue, and as we explore the 0th index,
And why are we putting in the queue?
0.
No. Why we are using queue?
So let's say we visit the index 0, there we find 2 keys. So we will put those whatever value we
No.
find.
So my question is like, why are we using key? Queue to store keys.
Because as we find keys, we can basically try and explore
No,
those.
so
rows.
like, why can't we use array? Let's say, or let's say something else. Like,
We can also use
Can
array.
use hash maps.
We just have to still remember what we basically what we have. Like if there are multiple keys, then we need to remember we had multiple keys to mark.
yeah. So for marking, like you can use an array. Let's say Boolean
You
array.
can use the map also, right? If it's already
Yeah, map. Nothing is fine. Yeah, I can see some interesting suggestions. So Rupai says we can model this as a graph problem. How we can model this as a graph problem? Rupa, can you explain?
Let me see. So I would say when we actually go visit the first like 0th index, we have all the key like whatever keys we find. That means there is an edge from 0 to that path, right? So that way, either we can actually go ahead and create a graph like adjacency list first, and then use a BFS or DFS, and then traverse the entire graph. And if all our visited arrays, like all the nodes are visited, like all the rooms are visited when we finally complete our graph traversal, that means we can actually do it. Like the answer is going to be true. If anyone is not visited, then the answer is going to be false.
Yeah, that makes sense.
Yeah.
Yeah, I mean, yeah, like we can represent this as a graph. Like let's say if we have, so this is the example one, input one. So again, given that 0th room is unlocked, that means we can go to room 0 initially without any key. We don't need any key. So our starting point could be room 0. And then the keys inside that room 0 will be could be the neighbors of room 0. That means like from that room I can go to these rooms, right? Like in example 2, we have some writing that as well. So in example 2, we have, so it's 1 3, then we have 3 0 1, and then we have 2, and then we have 0. Right, so in the example 2, again, let's say our starting node could be 0, but from node 0 I can go to node 1 and I can go to node 3. Okay, because I have the keys for like room 1 and 3. That means from 0 I can go to any of these 2 rooms. Okay. And again, if you again, like here in this case, in the room 1 we have the key for room 2. That means from room 1 now I can go to room 2. Okay. Again, like this graph might not be directed, so simple age is fine. I'm just showing that like this is the path we can follow, right? So this might not be this is just about the path, right? Okay. And again, in the example 2,
sorry, actually it's a directed graph, right?
Yes, you can think like that, but again, it's not about the order, right?
Yeah.
So
order
but
doesn't
yeah, like
matter,
that,
but
but the data
order doesn't. Yeah, order doesn't matter, but direction is important, right? From 1 we can go to 2, but from 2 we cannot go to 1.
I mean, actually, we can again go to like from 2 again. We can go to 1, right? Because like now I have the keys for room 1, so I can go to room 1 again. But again, like visiting the same room would not make more sense. That's why.
Okay.
But actually, like from room 2, we can go to room 1 as well, right?
Yeah.
But given that like we already have visited room 1, so I mean that would not make more sense to go to that room again. So yeah, I was showing that arrow only for the direction. But anything is fine. Actually, you can think this as a directory graph as well. That won't harm us, right? Okay, so now from room 2, again in the room 2 we have key for room 3. That means okay, now from room 2 I can go to room 3, right? In the example 2, again in room 1 we have 3 keys, right? We have key for room 3, we have key for room 0, and we have key for room 1. That means okay, now room 1 has, you can say, 3 neighbors, right? Or actually we can I mean, yeah, representing this as a directory graph would make things more clear. So let's say we can use this array, but actually this is not needed. We can solve this without this array as well. That means now from node 1 I can like room 1 I can go to room 0 again, I can go to room 3 again, or I can I can be in the same room, right? Because like 0 is also, I mean, we have the key for room 1 as well, right? But again, like this edge won't make any sense. But yeah, these are the 3 options I have. Like from room 1 I can again go to room 0. But again, given that room 1 is 0 is already visited, so I will not go to room 0 again. From 1 I can go to room 3 because that is not, let's say, yet visited. Let's say I'm visiting using DFS, then from node 0 I can go to node 1, and then from 1 I can go to 3, right?
Sashi, can I ask you a question here?
Yeah, sure.
In the second example, if you had 2 in the last instead in the fourth element of the array, if you had a 2, I'm talking about the rooms, the second example.
Yeah, you're saying like here we can, if we have 2.
If you had 2, then would we get a true for this?
Yes, because from 3 we can go to 2, right?
Yeah. Yeah, makes sense. Thank you.
Right.
Shashi, I have yeah, I'm just thinking, right? Like a lot of people gave us a graph, right? Like, so I was thinking to create an adjacency matrix, but it's already in the adjacency matrix.
Yeah, we don't need to build the graph. Yeah.
So in that case, right, like somebody gave like to add in the queue. Either we can add in the queue or stack, it doesn't matter. If we just loop through this thing, whatever the data structure is given, right? If we loop through and see if that particular room is visited, right? All we need for the result, true or false, nothing else, right? We are not building any data structure, right?
Yeah, we don't need to build the graph because yeah, I mean that list itself is a list, right? Because like so this rooms 0 is nothing but, sorry, let's say rooms 1 is nothing but so it is representing the set of keys within the room 1, and we can consider these integers as the neighbors of node 1. That means okay, from node 1 I can go to these 3 nodes, right? Or these 3 rooms, right? Okay. Yeah, so yeah, we don't need to build the graph because this information is enough to know the neighbors of that room or that node, right?
So that we can loop this, and we might need a simple data structure like memo. In memo, we create something, right? Memoization like that. I'm not confusing. I'm just trying to say like one array to store whether it is visited or not.
Yeah,
right?
we need a visited array because we, again, like here also, like if you see, right, I mean from node 1, I mean I can go to node 0, right? So we should keep track of the visited nodes so that I will not enter the same room multiple times, right? Because I mean I might get the same keys like if you see here, right? I mean I have key for room 3 here, I have a key for room 3 here, right? So I should not visit the same room multiple times, right? That's why we need a visited array or something. Yeah.
So in that case, it's I'm thinking, but we will work through. You will show us. So looping this data structure and storing and visited, right? Checking that it should solve, right? And after from that visited, we can check if that each room.
Yes. Yeah,
right?
that will work. Yes.
Actually, I have a question. Looping through this data structure won't solve this problem, right?
I mean, recursively. So looping means, yeah, like we can't.
Because,
So basically,
for example, room, like, there are like two indexes.
So looping, I think looping, by looping means like we are starting from, let's say, node 0, and then it's like we are trying to visit all the nodes, or we are trying to enter all the rooms where we can enter, right? So it's a recursive call. Of course, we can use recursion in DFS, or we can also implement BFS, but we'll have to use a queue. So I think looping means like
right,
just talking
you
about
have
that
to
only.
use either stack or queue, right?
Yes, or recursion. I mean,
or recursion basically gives the in-memory stack, but
yes,
to solve without recursion, you will have to use stack or queue.
Yes.
Because if you just loop through this, like,
I think I mean, yeah, I think she meant like
that's what I meant. That's what I meant. Going with each node using stack. I think you only gave the queue approach, right? Even stack would work.
But I was listening. I just got confused. Like, I think because if there is no key, that we cannot go to that index basically. That's
right.
why.
Right.
Yeah.
Okay. Now again, here, I mean, in the example 1, again, at room 2 we have key for room 3. That means, okay, now I can go to room 3. And then at room 3 we have key for room 0. But again, 0 was already visited, so we don't need to go to room 0 again. So again, in example 1, if let's say if I'm calling DFS or BFS from node. So let's say I'm going to call, let's say I'm going to use DFS because DFS is simpler to implement, simpler to code. It's recursive. So starting from, let's say, node 0, I can go to node 1, then 2, then 3, and then we are done, right? So at the end, I'll check if all the nodes are visited, all the rooms are visited. That means I can return true. Also, to get the neighbors of a node, I'll simply use that list. Like, let's say if I'm at ith room, or I would say ith node. So your room is nothing but the graph node. Okay. And to find the neighbors of that node or room, I mean, I can get that information from this input list of lists. So basically, rooms of I would give me the neighbors of ith node or ith room, right? So I'm not building the graph because I can get the information of neighbors from this input list itself, right? Here again we have room 2, and within the room 2, like again we can create a self loop like this. Again, that won't make any sense, but I'm just showing you that. Okay, like that means, okay, from room 2 I can go to room 2 again, right? And then from room 3 I can go to, let's say, room 0 because I have key of room 0 in the room 3, right? So again, if you see, if I'm starting from node 0, I can go to node 1, I can go to node 3, but we can't go to node 2 because there is no path, right? And in other words, we don't have key for room 2 in other rooms. I mean, we have the key for room 2 in that same room. So it's like self loop, right? So this is called self loop. Basically, if a node is, if node has, so let's say if a node has an edge to the same node, that is called self loop, right? In graph. But again, like, so that means like 2 has only one neighbor, which is that node itself. So from that room, we can only go to that room only, right? And there's no other path. Like there's no, basically we don't have key for room 2. That means we can't go to room 2. That's why in this case, because given that we are not able to visit this room 2, we are not able to visit the node 2. That means we can return false because all the nodes are not widgeted after the end of DFS call. Does that make sense? Like how we are finding the neighbors of every node, like how rooms of I will give me the list of neighbors for the node I or room I, and how DFS can solve this. Does that make sense? Again, like here order will not matter, right? Like let's say node from node 0, let's say I'm calling DFS from node 0 in the example 2, right? Then from 0 I can go to node 3 as well, right? That won't matter. Okay. And then again, node 3 has only one neighbor, node 0, and that is already widgeted, so I'll not go to room 0 again. So basically I'm kind of done with node 3 DFS, so I'll return from here. And then again, 0 has one more neighbor, because in the room 0 we had 2 keys. So from node 0 I can again go to DFS 1. And again, like this node, this room has 3 neighbors, node 0, 3 and 1. And actually all these 3 nodes are already visited now, right? So when I'm visiting room 1, I found 3 keys for room 0, room 3 and room 1, and all these 3 rooms are already visited. So I will not call the DFS from the neighbors of this node, because these neighbors are already visited, right? That means I'm done with DFS of 1 as well. Yeah, and in this case, like from node 0, because that is the starting room I have, we can go to room 1 and 3 only. We are not able to reach to node 2. That means we should return false, because we couldn't enter all the rooms. Of course we can use BFS as well, so both will work, right? But starting the source node of BFS or DFS should be node 0, should be room 0, because we can start only from that room, because that room does not need a key to enter. And again, for keeping track of visited nodes, we can use an array, because given that all the IDs of rooms are in the range of 0 to n-1, so simple array of size n would work, or you can use hash map as well. So anything is fine. So I'm going through some of the
Shashi, one suggestion. Can we use a set instead of the other data structure? So what we can do is, we don't have to worry about repeating keys as well, right? And then as soon as we get a key, we put it in the set and we put it in the visited array, right? And then
so you're using both, like you're using like set and visited array.
Yeah, I mean, I was trying to see if I can avoid the visited array. So if you just use the
so how you're going to other nodes, like so are you using like recursion as well, like are you using DFS as well?
No, so let's just say I'm just looping through this, right? I'm looping through the given input, correct? And I keep adding the keys into the set, right? And I check it for the current node or the current room I'm in, correct? So you know what I mean, right? So at 0 I will
sorry I was disconnected. Sorry,
okay,
you can repeat again. Yeah,
you can hear me now, right? So
yeah, I can hear
let's just say I start with looping the given input, correct? Or going through the input. At room 0, I have a key for room 1. So I put 0 and that key in the set, correct? I go to room 1. I see that there is a key for room 1. So I go to room, I'm able to go to room 1 now, right? And then in room 1, I see the other keys. So if at any moment,
so like how are you traversing the rooms?
You will still need the recursion along with the hash set. If you want to use the set, you will still need to use the recursion.
Right. I mean, we need something recursion, or let's say basically BFS or DFS to go to all the
You can
rooms.
just check the size of the set. If it is like there as the size of number of rooms, then we can return true or else false.
Okay, I'll brainstorm it a bit more, but yeah, please go ahead with the solution.
Yeah, sure.
Thanks.
Okay. So let me. So I hope this logic makes sense to all of you, like how we can use BFS or DFS to solve this. So let me write the pseudocode quickly. One second, I'll have to refresh this. Okay, so we have let's say that Boolean. So we have that Boolean function, which is the function name here is can widget, right? So that is the main function we are given, and the input is rooms, which is a list of list, right? So within that function, what I can do is I can have, let's say so basically I can find, let's say n is nothing but the size of, or I would say the length of this input list, which is the number of rooms. And then I can create, let's say, another Boolean array to keep track of widgeted. So I have basically a Boolean widgeted array of size n. And initially, let's say everything is 0. 0 means it's false, right? So let's I'm initializing the array with false values, right? False means let's say these rooms are not yet widgeted. And then I'm calling basically DFS from node 0. Okay. And in the DFS call, I can pass this rooms because that contains the information of neighbors of every node. And of course, I can pass this widgeted array as well. Okay. And once I'm done with this DFS call, I can simply check. I can iterate this widgeted array again. So I can simply, let's say, again starting from 0 to n, I can check if any of the nodes are not widgeted. So if let's say widgeted of I is equal to 0, 0 means like false. So I can return false. That means we could not reach to that room, so return false. If all the rooms are widgeted, then we can return true. We can return true. Okay. And then again, this DFS will be very very simple. So in the DFS code, we will simply, so it's a typical DFS, right? So again, this DFS will not return anything. So I'm writing void. Void means it will not return anything. So in the DFS call, we have the, let's say, source node S, or you can say start node. And then we have rooms list of list, and then we have that widgeted array. So in the DFS call, again, we'll simply mark that a start node or source node as true. True means like visited. So true means like it's like I'm marking that node with 1 or true, right? True means that node is now visited. And then I should check the neighbors of that source node. If that neighbor is not yet visited, so I should call DFS from that neighbor, from that room or that node, right? So basically, I can start from, let's say, for I can write like this, like for neighbor. So now how to get the list of neighbors for this node is, right? So basically, rooms of S, this list would give me the list of neighbors of this source node, right? So basically, I'm iterating in that list, the list of neighbors of that node. And if that neighbor is not yet visited, so let's say if that neighbor is not yet, so again I'm using 0 and false, so you can use anything. So if this node is not yet visited, so I should, in that case, I can call DFS from that neighbor. Okay, and again in the DFS call I'll have to pass the rooms and this visited array. So yeah, so this is the simple DFS call, right? Like typical DFS, right? We are simply visiting the node. We are we are marking that source node as visited, and then we are exploring the neighbors of that room, that node. And if that neighbor is not yet visited, then I'm calling DFS from that node. And again, at the end, like once I'm done with this single DFS call starting from node 0, if any of these nodes are not yet visited, so I should return false. Okay. Otherwise, I can return true. So I hope this pseudocode makes sense. Any doubt in this solution? Anything which is not clear?
So can you explain the for loop? I'm kind of confused of the for loop. If visited is equal to 0.
This for loop?
Yes.
So here I'm checking, like if so like how do you know if we are able to visit all the nodes or not? How can you check that?
Using the visit array.
Visited array. Yeah. So basically, I'm iterating in this visited array because this visited array will have size n, right? So I'm going through all the rooms one by one, or I'm going through all the nodes one by one from 0 to n-1. If so, this is the like visited array. So I should write visited. Like this is visited array, right? So if that is false, that means we could not reach to that room, right? We could not reach to that node. In that case, we are supposed to return false, right?
Yep, makes sense.
So this loop is like basically we are going through all the rooms or nodes to check if if you could not go there, then return false. Otherwise, return true.
Means that this is kind of connected graph, start from the node 0, from the room 0, right?
Yeah, basically all the rooms should be reachable from node 0, yes.
So this is a connected graph, okay.
I mean, the graph might not be connected. Like let's say here.
No, I mean, like, if you return true, that means it's connected.
Yeah, for true it should be connected, yes. Basically for true, we should be able to like go to, we should be able to reach all the nodes from node 0, yes.
So one more question. Sorry, go
ahead. I just think it's for the BFS solution, we're just using the queue, and each time for every unvisited node, we just add into the queue, and just for the next iteration, we just pop up mark as visited and add all of the non-visited till the queue is empty.
Yes. Yeah. So we can implement like this this thing using BFS as well. In BFS, of course, we can use a queue. And again, at the end of the BFS, we'll check if same thing, right? If any of these nodes are not visited, so return false. If all the nodes are visited, then return true. Yeah, so we can do this using BFS as well.
So Shashi, this is DFS recursion, right? To use recursion, we can use stack, right?
Yeah, we can use a stack as well. Yes.
Okay. So, and we pop it, right? Like initially we put into the stack. Initially we put 0 into the stack and we loop through, and first we pop from that, and same checking condition, this checking condition, and add the other neighbors into the stack, right?
Yes. So basically, instead of calling DFS recursively here, I'll have to add this neighbor in the stack, right? And the condition could be like this: while the stack is not empty, we'll keep doing this. We'll pop a node from the stack, and so on, right? We'll go to the neighbors of that node. If that neighbor is not visited, then add that neighbor in the stack. And same for actually BFS queue, right? Like initially we'll push node 0 because that's the source node in the queue. And while queue is not empty, we'll keep popping one node at a time from the queue, and then again we can mark that. In fact, when we are pushing the node in the queue, we can mark that node as visited. And after popping that node from the queue, we can simply go through all the neighbors of that node. So I can actually quickly write that as well.
We only push unvisited node into the queue.
Yes. Yeah.
So when we pop, we mark visit and push all the unvisited neighbor to the queue.
Right. So yeah, basically, like in queue also, we will simply initially we'll add, let's say, node 0, and then while let's say queue is not empty, so I'll let's say simply pop it, let's say node T from the queue. So it's queue dot like front, or let's say
front, right? So basically
top actually, or maybe.
I mean, depending on the language, right? So like in Java, so Paul means you are popping the front of the queue, so it also removes. So anything is fine. So basically, this is the front node, and also I'm removing that node from the queue. And then I will simply, and yeah, so when I'm pushing a node in the queue, I should mark that node as visited. Okay. And then here again, same thing. I will go through all the neighbors of this node T, which we have popped from the queue. Again, if that neighbor is not yet visited, I should add that neighbor in the queue. Yeah. And then of course I can mark that neighbor as visited here. Okay. So this is within the for loop, and again this is the end of this while loop. And here we can check if all the nodes are visited or not. So if all the nodes are visited, then we can return true. If not, then return false.
A quick question. Let's say if we move the mark visited after the poll, will this code still run correctly?
Yes, but in the queue we'll have but yeah, we might be pushing the same node multiple times in the queue. So that should work. So you're saying like we are marking that visited thing here, not here, right?
After, yeah. So we mark T after, we mark T after the poll. So you poll, and we get the node T, then we mark this T as
basically like here we are marking that node as visited, and then instead of marking that here,
I don't know whether this work.
Yeah, I'll have to think, but actually in that case we might be pushing the node again in the queue, which is already there in the queue. So I can give one example. Let's say if we have node 0, then let's say 1 and node 3, and let's say from node 1 we have, let's say the node 1 has neighbor 3. So in this case, let's say I have popped 0 from the queue, and I have added 1 and 3 in the queue, right? Okay, and let's say you're saying we are not, if you're not marking this node 3 as visited here, then node 3 is not yet visited, right? So when I'll be popping the node 1 from the queue, right? Again, node 1 has a neighbor node 3, and given that we have not yet marked that node as visited, so we might push this node again in the queue. Does that make sense?
Yeah.
So that's why we should like mark it visited when we are pushing in the queue.
Makes sense.
Yeah. Now, what about time and space complexity of let's say BFS or DFS? Any thoughts?
Order of n, time, both.
Yeah, for BFS or DFS, time is like normally V plus E, right? Number of, what is the number of edges, right? Here V is nothing but number of like nodes, which is n. And what about number of edges here?
Edges is visited, right? Like, sorry.
Okay, so for any graph, right, for BFS or DFS, right, if you are doing, if you're trying to visit all the nodes using BFS or DFS, then time is nothing but V plus E, right? Because we go to every node and then we also go to every edge, right? That's why it's V plus E. And yeah, here the number of vertex is n for sure because we have n rooms. But what about edges? Like how many edges total we can have?
The keys that you find in each room at the edges, right? That's the relationship.
Right. Yeah, like let's say basically in every room, let's say we can have keys for every other room, right? So what I'm saying is, let's say basically every node could be a neighbor of every other node, right? I mean, I have shared this example multiple times, but like let's say we can have a case like this as well, right? Like let's say every node is a neighbor of every other node, right? Okay. In that case, the edges could be in the range of n square. But if you see the constraints given here, it says that the sum of all the number of keys is less than 3000, right? Which is nothing but actually edges, right? Because like let's say if rooms, let's say I has total k keys. So let's say if the size of room I is k, that means that room has k keys, and that means that means basically that node has k neighbors, right? And that means that node has k edges, right? Okay, so basically this room, the size of this room I is nothing but the number of neighbors, which is nothing but the number of edges, basically edges going out from that node, right? And it says a total, it won't be n square, it will be at max 3000, right? It's given in the problem that okay, total sum of the length of these arrays won't exceed 3000, okay, which is in the range of n only, because here n could be 1000, so it's kind of 3n at max. So yeah, so here given that it's 3n, that's why we can act like it's n only. So total time will be big O of n itself, okay, because here, I mean, given that the number of edges won't be more than 3000, that's why it's big O of n. Does that make sense?
Would you be able to call it theta of n? Because given the visited array, you won't be visiting those duplicate keys multiple times, right?
But we can be visiting the duplicate edges multiple times, right? Because we check for the neighbors, right? When I'm checking for the neighbors here, right?
That's true. Okay.
I'm not going to the node, but I'm checking for I'm checking for all the neighbors, but that means I'm checking for all the edges, right? That's why we should also consider the number of edges, because for every node I'm checking for all the neighbors. That means I'm checking for all the edges. Okay. So yeah, so for both BFS and DFS, time will be, it will be big O of n in this case, and the space also will be again big O of n for visited array, and then big O of n for a stack or queue. So yeah, it's big O of n only. Any doubt, anyone? Anything which is not clear?
Can you remind me what's the formula to calculate or the maximum age?
So maximum age could be
when choose two. Is that the formula?
Yeah. So let's say if we have directed. So let me explain it here. So if we have directed graph, so let's say if we have n equal to 4, right? In that case, let's say in the worst case, every node is a neighbor of every other node, right? Okay. So if you think about all the possible edges, it will be something like this, right? Which is nothing. So that means basically every node has n minus 1 neighbors, right? Or I would say n minus 1 edges. Okay. Basically outgoing from that node. So total edges will be nothing but n cross n minus 1. Like in this case, if we count total number of edges, it will be nothing but 4 cross 3, which is 12. So total we have 12 edges in this graph. Okay. So at max, in a normal graph, we can have n square edges if the graph is directed. Does that make sense?
Yeah, that makes sense. For the undirected, we just divide by 2.
Yeah. So in case of undirected, given that like we will consider both the nodes as both the edges as a single edge, in that case it will be n cross n minus 1 by 2 in case of undirected. But yeah, in both the cases it could be n square, right? So this is also n square. Okay. Okay, then I'm done from my side. Yeah, Soham is there. Hi, Soham.
Hi. Okay. Does anybody have any more questions for Shashi? No.
Yeah,
okay.
Looks like they're good. Yeah.
Good.
Okay, thanks.
Of course. Hi, guys. Welcome, everyone. Thank you for coming in. Some familiar faces, many familiar faces here. Some new ones as well. So just a quick thing. This is time to just ask, and just a free flowing discussion type session. Monday nights. Feel free to ask questions. I'll be happy to help chime wherever I can. But I think more of a group discussion would be useful. You can ask questions on markets. You can ask questions on ML, AI. You can ask questions on really anything else that's on your mind. In the past, as you know, we have had discussions on various different things. Feel free to ask again if you feel like you need some more clarification. All that good. But any feel free to share any anecdotes from the market. Any interesting companies that you think are hiring, that are hiring. Sorry. Any of your friends who recently found roles, just to share any anecdotes, anything that could be useful to each other in this. And obviously, if you don't have any questions, feel free to listen in, feel free to chat. All that is good as well. An anonymous participant is asking, how is the job market right now? Bad. Right now it is bad, but hear from others. How is the job market right now, folks? Somebody's asking. What's the pulse? Summer is over. People are coming back from vacations. Some people are waking up to vacations because they worked through summer, and now they are trying to find deals and go places and looking at, is there a long weekend coming? Oh yeah, there is one. Labor Day coming, so this will be that. But otherwise, how is the job market? What do people think? Any interesting experiences recently? Feel free to share again if you shared in the past. Yes, Umesh, go ahead.
Hi, Soham. Hi, everyone. Yeah, I think this one is a good starting point to talk about what is the pulse. And at my personal level, I think I'm keeping a tab on the job market and the pulse of openings through LinkedIn, through Hired, through the news, etc. And it's quite intriguing that even though the market, in conversation seems to be slow, but then there's so many listings of openings. It doesn't seem so in at least LinkedIn network, but I don't know what are others' experiences are. Like, do they apply? Do they get any responses based on those job postings? I applied for like couple, and then haven't heard from one of them, but got a rejection stating they've gone ahead with another candidate. But how does it work? I was wondering about this.
Sorry, before others answer, I would love for others to answer. Just to qualify this question a little bit more. Question for Umesh, you and others as you're answering. Is this the first time you are looking at LinkedIn and other job postings this way? Or have you looked at it in the past also, say 2020, 2021, early 2022? And what difference do you notice when you look at today and last time? Yes, sir. Go ahead.
In terms of openings, I've been keeping a track of the job portals for years now. I think because of my professional experience. So I would say I am aware of all the job portals. Specifically, LinkedIn has matured a lot in my experience, meaning now we get to see the salaries, we get to see, of course, the job descriptions are quite detailed. But what I don't understand is how does it work in the background, meaning a job poster comes out on LinkedIn. I'm sure they're getting many applications, but as we hear, that they probably received 1,000 and then they don't get enough time to sift through. And then there are certain deadlines against which they have to close those postings. So is that pretty streamlined, or is it really that we're just shooting in dark when we apply for these links and it just might go into any bucket that is not looked at?
What have others experienced?
Hi, Soham. I'm applying daily through the careers section, so of different websites. I recently started applying a lot, but I'm still waiting if someone gives me an interview call. But last week in the past I did an interview with Google, but it did not go well. So they happened to ask me about a linked hash map structure, but I was unaware of it, so so it did not go well. And
so when was the Google interview?
It happened on 18th of July. And
I see. So Google did respond.
Yeah, they did. Yes, they said I can apply again in 6 months to 9 months.
Right. When did you apply and when did they reach out?
Oh, I applied in June. I mean, previously I was applying in all the months through different email IDs, but in July I applied through one specific email ID and I got a response somehow.
Interesting. Different email IDs, not different LinkedIn profiles, I'm guessing.
No. Same LinkedIn profile, but different email IDs somehow. Yeah.
That's kind of weird. Like, do you see any better uptick if you submit the same resume from different email IDs?
I have used older IDs. They somehow a lot of my older IDs got rejected, and so that's why I wanted to. Yeah, that's why I wanted to use a new profile, new ID, so that there are specific recruiters that are going against my email ID. So last year, one recruiter reached out. So I last year I was not ready to take the interview, and when I got back to them in January and February, they said we can't do it now because there are not a lot of positions, and they gave me a specific recruiter name who is handling my case. But when I switched my email ID, a different recruiter is handling again. So I don't know. Based on the ID, they are going for a specific recruiter, I guess.
I see. So same resume.
Yeah, it's the same resume. Yes.
But different email ID, different. And this, you're not talking about a contracting company. You're talking about a full-time role, a regular company.
Correct. And
it's kind of weird.
And I have another question. In case if H1B is not, I don't have so many months of H1B, will they find out a way? They have this doubt. Do they usually figure out a way if I got hired or something with any of these companies?
Sorry, I don't understand quite. Like, if they will ask you, right? In the process, they will ask how many months are left. So
this company did not ask. Maybe in future, a few other companies might ask. So if I don't have a lot of months left, and if they happen to file, if they need to file the perm and stuff, but I don't have a lot of months, will they figure a way out? It's a green card process.
Yes, I mean I think I don't think there is like an absolute answer to that. It is very company dependent. So obviously, I mean, where you are, what role it is, what other offices the company has, what does the hiring manager think? How big part of it is how was the interview? If they're really excited about you through the interview process, they go further. These things,
right?
And company to company, it'll be different. Some of them will also have policies and stuff like that. Yeah.
But Soham, does it matter how many months he has having on H1B? If he already have I-140, it get extended, right? It doesn't matter.
I don't have. Yeah.
So you need to apply a green card. You I-140. Otherwise, you can't switch if you have very less time on the.
Right. My current firm is doing, but I'm trying to switch out. Yeah.
So different people and different conditions. So, it's a very like detailed subjective thing you have to dig in. But keep trying, Shikha. Keep trying. Market certainly has gotten better compared to earlier this year. Compared to Q1, market is certainly better. It is not as to the level as we have been used to in 2020, 2021, but it's certainly better.
Right. Okay.
What about others? What about some other job experiences, like job search experiences these days?
Yeah,
one at a time. Yeah.
Market is a little bit better, I experience, but I think with the LinkedIn, I have applied quite a few, and I don't see anything actually. There is not much reciprocation, and I have like couple of friends also in the same boat, and they are experiencing the same thing. With the LinkedIn also has the easy apply or something that is basically never been looked at, but even if like other applications through LinkedIn are also not much given attention to.
Yeah.
It's like if recruiter reaches out through LinkedIn, then it's a different story. Yeah. But you just going out, it's not much success I had.
Somebody else also wanted to say something?
Yeah, hi, Soham. Hi, everyone. In my case, so a Google recruiter reached out to me in mid-June. So they wanted me, they asked me about how I was doing in my career if I wanted to apply. In my case, I said for now, no, I didn't want to apply because I was concentrating in my I'm studying the ML switch to ML. So I said no, even though I didn't have I was not employed at the time because I was laid off at the beginning of the year, and I thought that market might be shifting to be better, right? Because I mean, again, companies were reaching without me like having applied actually. But later on, I received an invitation from HackerX, which is some organization doing some. They gather like a series of companies, like might be startups, and they invite like developers, engineers to go there and apply, like interview with the people, hiring managers, etc. So I said, well, it won't hurt if I go, if I like actually accept the invitation. But strangely, this was canceled. Like this happened in this month in July. So and the reason that why they canceled this, they said market conditions. So it was like strange to me to hear that because I thought that the market was shifting to be better. I have been in that event before, like good companies were there before, like Lyft, Uber, etc. Like in the past, like some 4 or 5 years ago. So yeah, that's my experience. So now I'm employed, but yeah, so that's one thing.
Different stories. Very good. Okay. Thanks for sharing us. Very interesting story. Okay. So in general, yes. I mean, market still is not very good. Like, and basically, supply is more than demand, right? You apply to a LinkedIn job, really anywhere, you're not getting reached out. What could it be? LinkedIn is not very cheap to advertise on. A few $1,000 a month per job description, right? They charge. So why would companies post jobs and not respond? Unlikely. There are some companies who do that. They just want to show a good face, right? This, that, the other thing. But most companies, right, when they are in a crunch, they don't want to be spending thousands of dollars every month on LinkedIn to just keep jobs posted and not entertain any applicants. So yes, there are companies who signed long contracts with LinkedIn and now they're in the contract, so just like keep the jobs open. There are companies like that. But many companies renegotiate those contracts with LinkedIn and they won't post jobs. So the only plausible logical reason there is just supply is more than demand. It's like more people applying than before, and among the people applying, the average background of the candidate applying is higher. It's better than what was found in 2021 2020. So companies give that shot, right? And so when you get called, that means like a lot of these people applied, but your background actually was impressive, right? So whenever you get called, try and dig in and ask, like, what made you call me, pick my application? Do you even talk to the recruiter? Just ask them, and once you have few of these conversations, you will notice some things that people like on a resume, something that people like on a background, okay? And do more of it after that. Otherwise, there are lots of conspiracy theories going on in the market. But most of them don't make sense. The only thing that makes sense is that we have just much more supply than demand right now. Right? On Hacker News this week, there was a thread. I don't know if you guys picked up on it. this exact same topic. If you read, let me see if I can find it. It's a long thread, but there are some really interesting nuggets in there as well. As usual, there is hate for algorithmic questions and stuff like that, but let me see. But there are also some very smart comments there, very like level-headed comments there as well. So just for you to read patiently at some point when you have time. Yeah, here. 700 points in that thread. Look at this. And remember, this is a free form discussion board. So these are just people's opinions. Like, these are not theories. These are not gospels to take on and run with. But when you read it, you will notice there are some very nice nuggets at play, like nice advice, like just comparative analysis. It'll enhance your understanding of the market. So there are some 700 comments on this in a matter of like 3 days. So it is something top of mind for people. You're not the only one struggling with it. A lot of people are, and there are people who are helping as well.
And so, what is conspiracy theory you're talking about?
Conspiracy theory is like people feel like these, like conspiracy theory about United States never went to moon, for example. That's a conspiracy theory. They actually went to moon, and some people just say it like that. Like companies, in the job market, there is theories about companies interview you all the way to the end just to show that they are interviewing people. No, nobody really does that. Like companies will not spend a single minute with you if they can get away with it. Or anybody, like you wouldn't in their place. So like there are theories about frauds. Most companies don't do fraud. Like vast majority of companies are just like they straightforward want to build a product and get it out. Those things are going on. Like the news media these days, last several years, ever since I think people have started gaming SEO, ever since like lots of channels on TV are coming up. Like there's like a hunger for news, and how much news are you going to get? And so people just make up a lot of nonsense. WhatsApp, lots of stuff goes on around, and so many people fall for it. Like frauds in job markets, they happen, but like it's pretty rare. But one person posts about it and that becomes like a thing, and then people just make rumors upon rumors on top of it. Like I think the close approximation to conspiracy theory is a rumor. But yeah, so don't fall for those things. Just keep your eyes on the road. Right? You work for it. You consistently apply. Keep improving. You get in. And that path remains straightforward and clear. That's fine. The laws of market apply, supply, demand. Applies to everybody. There are trends in the market and there are not trends in the market. Those apply to everybody. So the rest is just like noise. That's what I mean. Let's see. Stock market seems doing well. Do we hear anything about possible good turn in the job market soon? So yes, I mean there are. Market is better now than it was in Q1. It is, or last year Q4, like distinctly better. And IK, we are seeing a lot more conversations now. It's still not easy for candidates. Like it's still questions are harder, and supply is more than demand, but it is better. It is going in the right direction. There is optimism in the market that recession is going to be avoided. It is not going to be a free fall. It's a soft landing, so to speak. So everything seems to be going fine right now, but these are very delicate things. So, and it's all like a global this thing right now, right? So you can't really you can't really rule things out. Some moron in some country does something and invades some other country, and you have completely different ball game after that. So those things can happen, but otherwise it's on the right track, really on the right track. Faang hiring again. Hi Rupal. Yeah, so like we saw Google, Amazon, no, not yet, not appreciably. Apple, yes. The Netflix, yes. Meta has started, yes, as well. Not much. Few openings are coming out in Meta as well. So yes, those companies are hiring. But yeah, generally like slowly and steadily it'll pick up. Let me know if you want to know anything else, or if I know, or ask others as well. What about age discrimination? Is it worse with this market? It has to be, right? Absolutely has to be. Age discrimination has been a problem in the industry for some time, and realize that it is now that people above 35 are hitting the market, right? Like software engineering didn't have these many people earlier. So now the people are 35, 40 are like, there is slowly, steadily hitting them, more people like that hitting the market. So age discrimination, age problem is going to get worse as such. That's one. Two, on the positive side or negative side, how I want to think about this. The shelf life in our field is generally low. Like you make a lot of money early, and then it's relatively harder. But again, most of these things apply if you want to remain an IC, an individual contributor. If you want to go into management and climb the management ladder, like that's age discrimination doesn't apply. Just that the number of openings are less. You need one manager for 10 engineers type thing. Even product managers you could go into, there is ages. There is age discrimination in product management also, because it's difficult to understand like the next generation of users, right? Once you're like 10 years away from it. And so 20 years away from it, you're like 2 generations apart. Like these days, the definition of a generation is like 10 years versus 25. So there is that as well. Program management, less so. But still there is some. So, but vast majority of people are individual contributors, so they face that. But again, I think that is also like one big reason one should work at a good company as early as possible in one's career. So like get some retirement savings, and then yes, it becomes a bit harder, but you can at least find a company that is like maybe not like a fast growing modern tech company, but Oracle and Cisco's of the world. You can find a position and stay steady if you don't want to, if you're not ambitious about it. Obviously, best way to deal with ageism is to be ambitious about it. Like keep pushing. I made offers in my life to people who were in 60s, grandpas, and they just like perform the same as anybody else in the interviews. We didn't give them a pass because of their age. In fact, they brought more to the table than younger people did. And how did they bring more to the table? Because they just kept up. They put in that effort to keep up with things. They continued to code. They continued to attempt new systems. Like you could have a conversation with them about mobile as easily as embedded systems. They just read about it a lot. That is one thing I've seen, and I've first-hand experienced. Engineers who read a lot, right, or watch videos and talk to other people, like that knowledge gaining, continuous knowledge gaining, right, they have less issues in ageism. Like they just like perform just better as well. So anyway, I know you didn't ask what the solutions of it, but generally, yes, it has to be. It is worse in this market. Is there a difference in hiring in tech in between the West and the East? See, Catherine, generally West does better. Right? West goes down faster, comes up faster, just because it is the Hollywood of tech, right? Same thing in Hollywood. Like if when the movie industry is down, like you feel it first in Los Angeles, and it comes back up in Los Angeles first, right? In elsewhere, movies are shot everywhere, but sort of where the mecca is, where sort of this action comes up faster. Generally, that's the case as such. Let me know if you. Anyway, and folks, I don't mean to be the Mr. Know-all here. Right? I am not. I'm just a normal human who continues to learn. And so, if you have anything else in these questions, like please feel free to chime in. You have opposing points of view. I would love a good debate any day as well, and I'm sure everybody would learn from different thoughts as well. So if you think differently, it's no, East Coast is better these days, Nashville is better than California. That's what you found. Like bring up and say, this is what I found. Don't hesitate.
So I'm curious, which companies are you most on?
Which companies come again?
Listed.
I can't hear you very well. Sorry, am I the only one, or is his voice not clear? I can't hear that. Yeah, okay, sure. So we can't hear you. Not just me.
Yeah.
Yeah. Go ahead.
Oh, sorry about that. Yeah, I was just curious, which companies are you most optimistic towards?
Most optimistic towards?
Or you think have the most promising outlook?
So, I am possibly going to die on the hill of the most innovative companies in tech. Like, what has happened is that progress is now synonymous to tech, and that has actually been the case ever since the Industrial Revolution. So, my entire worldview is just tech, and so my highest optimism is in tech level one. Zooming in tech, where are the most innovative companies? Right? Companies that make big bets. They're not hesitant about failing. Right? Companies that push the boundaries. Right? Which are those companies? You look around, really the Faang companies. Right? Like literally, Facebook made a bet on metaverse. Didn't work out. Fine, but they learned a lot and they moved the world forward in technology in many of the ways. Now they are going all after AI. AI is working for them. Apple, same thing, like extremely innovative as a company. Amazon didn't mind failing multiple ways, but look at it today. Like that's the same thing. Google, like OpenAI started with the thesis of beating Google. That was the thesis of generating of getting OpenAI. Google is becoming too powerful, and if they take AI, they will just like cross the boundaries. And so that is why OpenAI started. Like, so my optimism will always lie in tech. Will always lie with these big companies, because they will continue to push the boundaries of things, and then the rest of the world will follow. Yes, there are exceptions for sure. There are other smaller companies that are also innovating, but innovation these days has become very difficult. Like seminal needle moving innovation has become difficult without a lot of investment. So, and there are VCs who are writing big checks. Like Andreessen Horowitz has like billions and billions of dollars of funding, for example. So they recently gave $300 million to the guy who did Uber. No, sorry, WeWork, Adam Newman. So those deals do happen, but those are relatively fewer deals. And seminal innovation will come with a lot of money and a lot of intellectual prowess. All of that, fortunately or otherwise, is concentrated in maybe like 20 big companies these days. That's where my optimism lies. Now, if you want to zoom in even further to say which of these, that's a hard call. I think Apple has shown a lot of restraint in hiring people. They've shown a lot of maturity and innovation as well. So even though Apple is not technically a software company, the DNA is hardware and now supply chain. Design by hardware I meant design and supply chain. I am quite optimistic about Apple, quite optimistic about NVIDIA as well, because of the AI boost that they're getting, the GPU boost that they're getting. I am quite optimistic about Salesforce as well. Among the top 20 largest companies, I think Salesforce is going to get there as well. Does it necessarily make a great place to work? Not necessarily, no. I mean, that's another question. But sort of optimism about growth and sustenance and of the company in some sort of contribution to tech and moving the world forward in meaningful ways. I think some of these companies where my head is. Does that help at all?
Yeah, absolutely. I think there were a lot of interesting tidbits there. I guess my follow-up question to that is going back to your earlier statement around East versus West. Do you see a big shift into return to office versus more distributed workforce or otherwise? Do you think that there are competitive advantages to being into the Bay Area versus in 2021 you could be anywhere and apply, and they were full remote during COVID, right?
Yeah. See, I see the world going to hybrid, and again, I'm just another person with an opinion. It's not. Yes, I read about this a lot and talk to people, but which nobody really knows. So if I'm doing some crystal ball gazing, I see the world going hybrid more than anything else. There are significant competitive advantages being in a room with people and working on a project for an uninterrupted period of time. Especially if the companies are larger, they're just harder to manage remotely, much harder to manage remotely. So that is why all these companies actually went back on their decisions and said, no, come to office. You are fine 2 days a week, 3 days a week, but come to office. So what happens when you're in the office is that you're employing all your senses. You're learning and progressing and absorbing and responding through all your senses versus part visual and part voice, which happens remotely. And when you're there, you're shaking hands and you're looking at things and you're absorbing a lot just by being in that environment, which is why progress happens faster and the velocity of execution is faster. Small setups, that's more or less a wash. So small setups, smaller companies can, and they are already going remote, but so the larger they get, they will very likely go hybrid. That's sort of my bet. There's also dearth of tools. Some good tools should have come to facilitate remote working. They just haven't come. That is my biggest gripe more than anything else. Like by this time, there had to be like either features in Zoom or other tools which just like make it easier and easier for people to like feel like they are in a room even though they are sitting remotely for it. So that hasn't really happened. There have been attempts, but they're all not getting investment. So investors also now are going back to local. But yeah, is there an advantage being in the Bay Area? That's a bit of a coin toss. But if I were to bet today, if you were to restrict my bets to say yes or no on the Bay Area, I would still say yes. Simply because of the DNA there. Like there are very few places in the US which have a concentration of like high talent. Like Stanford and Berkeley attract really good people there. The weather is also there. People want to stay there as well. And if you don't have to go too far down to get Caltech and UCLA as well. So like from high school to college to like that funnel, right? Like yes, there is Boston. That's possible. There is Harvard and MIT. So that is one possible thing. But the Boston, the weather kills it for many people for it. and weather makes a big difference in these things. Like that happened in India as well. Like Bangalore weather is just like really good. Like, I mean, it has gotten worse over time, like everywhere else, but otherwise was really good. And that was one big reason that small, quiet military town transformed into a tech hub. And it's not like India has snow anywhere, but I mean, except obviously the very top, but like it did not come into places where there was excessive heat or excessive cold, like stuff like that. And so these things do contribute. It may not be the only reason for it, but these things do contribute for sustenance of these things. And so yes, right now commercial real estate is completely screwed in the Bay Area. Like you walk in San Francisco and you'll see like to let like everywhere.
I mean, not only commercial real estate, but if you're a person looking to purchase a home in the Bay Area, man, it's so competitive that even with like, you know, a regular Faang income, you're still getting outbid in that competitive real estate market, at least at the moment. But that's like a whole other conversation around the real estate market in itself, with high interest rates, et cetera, et cetera.
Yeah, that's it. So I meant the opposite on the commercial real estate side. Like there's like so much vacancy in the Bay Area in commercial real estate. Right? If you go to Garrett and O'Farrell in SF, like that intersection, like right opposite Four Seasons, was like you have so many places you can rent out. Like that is not Bay Area. You know, that feels like this is not good, but I think because of the other pressures, like over the longer period of time, medium term, because of the colleges, because of some history, because of weather, I think we're gonna sort of come back up. So that's my bet. If you want to make a bet, I mean, I could be wrong, but I think that's, if I were to make a bet today, that's what I would bet on. But is the layoff continued? Layoffs are less, anonymous participant. Layoffs are much less actually today. There was another small round at the beginning of July, but otherwise it's much less actually. Should the compensation be expected to be lower than usual? Yes, yes, about 20%. Just keep 20% in mind, give or take, but generally that's the case even at top companies. And you would expect that when the supply is higher than demand, and that's okay because the inflation is also lower, so you'll also spend lower. Now the Bay Area housing market obviously is a different beast, but otherwise inflation is lower as well. Though I'm still not spending, like it's not as low as I would like. And I think I gave this example last time, if I remember right. When we were physical in the Bay Area, with physical classrooms pre-COVID, I used to get sandwiches in the evenings, Thursday evenings especially, and Sunday mornings lunches for all the students. And I used to get sandwiches for like $11 all in, like with tax tip delivery, and decent sandwiches, or like those packed lunches and such, like good the ones that I would like to eat for my lunch and feed my family on those type of sandwiches and food. And that food is like still like $18. Like it used to be like $22-$25, and that's come down a little bit, but still like 18-20. It hasn't come back to like $11-12 for it. But so like 20% less, but that has happened in food also. So anyway, food is not the biggest expense as such. It's real estate. And real estate is sort of very specific to where you are. But 20%. Is the startup scene faring any better? No, anonymous participant. The only place in startups that are faring any better that I know of, and guys, again, feel free to chime in if you agree, disagree, anecdotes, is AI. A good chunk of the only sector in startup world which is getting any funding is AI, or like easily. Obviously, there are people getting funding, but like much less compared to the previous years. Right? They're all like spooked. Tech investments in general are like people are like, I shouldn't make those investments that time. So yeah, it'll open up. It'll open up. Give it some time. It'll open up. Like the world has to progress, and the synonym for progress is tech. Even going from writing with a feather to a pen was tech. Printing press was a tech. Making of paper was tech. So it is going to happen for sure. I wouldn't bet against American entrepreneurship any day, but give it some time. Krishna is asking, has anyone been observing the market to find the new or smaller companies that are on the trajectory to be top tier companies in the upcoming years? That's a good one. What do you guys think? There's a question on chat. Has anyone been observing the market to find new or smaller companies that are on the trajectory to be top tier companies in the coming years? Any bets? I mean, these are just bets, opinions. Anybody can have an opinion. You don't have to be right about it. I'm not going to hold it against you. No, nobody is.
I think Anthropic has something to be watched there.
Anthropic, okay. Okay, very, very good, very interesting, very observant. Okay. This one, okay. Huck has put a link in chat. Zip. Zip is the world's leading intake to procure solution. One best for employees to initiate a purchase of vendor requests. Interesting. Like a B2B SaaS, is it?
I believe so. I just have some former colleagues that work there, and they're some folks started it from Airbnb. I think they just raised a Series C or D, but they're still going through their Series A funding, and they have quite a bit of runway. So, I mean, they seem to have a very good outlook. At the same time, with any startup, the work-life balance is probably not the best. So, it just really depends on what you're looking to do at this point in your career.
Makes sense.
That said, I think that there's a lot to be said about companies that are also currently weathering the storm, so to speak. They understand that money isn't free flowing as it was, 1, 2, 3 years ago. So they're certainly a lot more pragmatic and conservative with the way that they're spending and hiring, and really taking into account the runway and overall economy. Which is also something to be said about, hiring across the industry as well.
Yeah, a lot of companies have gotten quite efficient over time as well. I showed this last time. I'll show it again. I think there is some optimism here. Maybe sorry. I think it's covering. 1 second. Hold on. Yeah. Okay. Now it's not going. Everyone is more efficient. What Thak just said. So many companies at 200 million plus ARR are still growing 30%. So I'm seeing buying pick up. Companies between 30 and 300 million in ARR. If you were to bet, like those are growth companies to bet on. Like past 30, those who are like comfortably past 30, they'll reach 100. 100 will reach 200. At about 150, 200 mil, you IPO. So if you are enthusiastic about any startup, anything else that helps you, like makes you feel better about it, like ask what the revenue is. Too early is risky. Depends on where you are in your life. Too late, may not have too many rewards. But 30 to 300 is a decent bet. Right. So there are several of these companies, right, that are they're aiming for IPO in the next year. So maybe I can find the list somewhere. Hold on, give me a couple of minutes. I think Jason had a list. Let me see if I can.
I guess I have another question while you look for that list.
Yeah.
How have the market conditions affected IK?
Hold on. 1 second. Just. Sorry, I just want to finish this. And IK is doing well. IK is doing well. We had our own slump as well, but we are now stable back again. There were a lot of people who said, "Oh, there are no jobs. Why should I prepare for interviews?" But there were also enough people who said, "This is the time." When if any time I need more help is now, and those people did very well. That is, I am. So we had a trough, and we are now back on this.
Just like many companies.
Just like many companies, yes, and we got more efficient. We
Right.
just got more efficient as well. Yeah, sorry, I'm not. Second, when did I see it? Oh, this is not ordered by. Okay, maybe next time. Yeah, the other thing you'll see is that various companies are increasing their prices as well, which is counterintuitive right now, given that inflation needs to be in this. But it's a small set of companies. Okay, I'll find it next time. It's taking longer than I thought. Okay, next time. So the companies that will likely IPO in the next year. So you could target them if you would like. Like they would likely be hiring as well. Everybody is like very, very cautious right now in hiring, but if you're IPOing in a year, then you have at least some gains built in. I'll find that list by next time. All right, folks. It's time. Thank you all very much for coming. As usual, one of my favorite sessions of the week. And let me know if we can be of any help. Write to operations, start with them. If I can be of help, start with me. So I'm at Kickstart. Okay. And hope you'll all have a very good evening. Thanks for coming.
Thank you, Soham.
Thank you, Soham.
Bye, everyone.
Thanks.